Okay, so one more the limitation what you see in the amplifier is voltage swing limitation. So voltage swing means what they are saying is in a linear amplifier, if you give a sinusoidal signal as the input, the output is also sinusoidal without any clipping. I told you the reason for using resistors in biasing circuit yesterday, because resistance is a linear device, right? So whatever the input you give, it will produce the output proportional to input. Amplifier also same. If the amplifier is linear, linear means if the amplifier is working in the active region where output is proportional to input, whatever sine wave you give, it will be exactly amplified at the output without any clipping. Clipping means gave you example, right? This is clipping. This portion of sine wave is cut, or this is also clipping. This I have clipping here in negative region. Here I have clipping in the positive region. So if the amplifier is not linear, these two type of outputs can come. That's why they use the word here, see, in a linear amplifier. So if the amplifier is linear, output sine wave will be looking same as input sine wave. There will be no clipping. The sine wave will be beautifully coming like this. Perfect, right? But if you have the amplifier is not linear or the Q point is slightly moving up or down, these two outputs you will get. So I can easily predict what is the maximum output voltage I can get from the AC load line. So if once I draw the AC load line, I can clearly predict what is the maximum output I can get. From the maximum output, I can predict what is the maximum input I can give to my amplifier to get that maximum output voltage. So it is just like reverse engineering. Because we are drawing all the load line in the output side, right? So we have knowledge about the output, but I need knowledge about the input. So you have to do the reverse engineering. So first analyze all the conditions for the output. From the output, you can easily relate to what is happening in the input because the amplifier is linear. Output is proportional to input. So I can predict what is the maximum output voltage. From that, I can predict what is the maximum input voltage. And if I don't exceed the maximum input voltage, then I will not have this type of clipping happening in my amplifier. The signal will be a beautiful sine wave at the output of my amplifier. There will be no clipping in the negative region. There will be no clipping in the positive half of your sine wave. The sine wave will be perfectly amplified as you give in the input. So I have to do that analysis to ensure that I do not exceed the maximum input what I can give to my amplifier. So that caution I should have in my mind while I design my biasing circuit. Okay, so if you give more than the maximum permitted input to your amplifier, this clipping or clipping of the output voltage will happen. Okay, so some either negative portion of the wave will be clipped off or positive portion of the wave will be clipped off, which will make your amplifier non-linear. Non-linear means output and input are not proportional or they are not same. There is some change in the output voltage which is done because of non-linear operation of your common emitter amplifier. The problem is not with your biasing circuit. The problem is with the maximum input voltage what you are giving to your transistor. Okay.